All right, last live stream. What questions y'all got for me today? No concurrent viewers. Well, just a few updates for anyone who is watching this video after the fact. Don't freak out about your lab practical grade. Blackboard is pretty bad about grading free response questions, so Monday, Wednesday, Saturday-ish, kind of freak out if your grade's still pretty low. But the plan is to go through your lab practicals today and tomorrow. Monday, if need be, to go through and actually go back and grade the free responses. A lot of you have taken in comments like, well, like it's giving me zeros on my free responses. Yeah, the pattern match in Blackboard is just atrocious. So that has to be graded by hand. Also, what I've commonly noticed is that some of you are missing that one of those is not a multiple choice question, is a multiple answer question. So just keep an eye out. If they're little circles, that's multiple choice. If they're little squares, that's multiple answer. Catherine's asking about connecting work. Yeah, go for it. What questions you got? Specifically, if you can give me a problem number. $27 and $29. So give me just a minute. All right, so question 27, this is what it looks like on my end. So question is asking you, you start with this compound. And you're going to finish up with your rearranged alkene. So the question is, what's the first intermediate? So if you have elimination by alcohol, almost always you're going to go through an SN2 intermediate. That's just the way they prefer to act. HSO4 minus 1 is actually a weak acid. It's kind of weird they would pick that, but H2SO4 is a strong acid, so there's no like going backwards with this. So your first step will be to protonate your OH group, give you OH2 plus, and this is going to be your leaving group. Oops. So this should be your first intermediate with the carbocation. So let's pop back. Now you're going to get rearrangement, which is what it's asking for in the second one. So for this one, you can kind of infer based on what the product is up here, what that rearrangement is going to be. But what you're going to get is a methyl shift. So right now we've got a secondary carbocation. If we do a methyl shift, what we'll end up with is a tertiary carbocation. Sorry. So we're going to get the methyl to move over. And if we put that in, wow, that's incredibly annoying. Tell you what I can do. It's the problem with doing it in not the teacher view. Hold on. Make sure this isn't a situation where it's being extra picky. Oh, I know what I did wrong. So when I drew the structure, I forgot to throw the methyl on that particular carbon. Just like I did on the board behind me. So for question 27, this is how it's going to progress, assuming you remember to throw the methyl in here. You're going to get the carbocation on the first where you've got the OH group, and then you're going to get methyl rearrangement to give you basically the alkene before it becomes an alkene. So you get that carbocation on the second carbon, and then hydrogen elimination from this one. For question 29. I'm going to bring it up so you can actually see it. Draw the structures of the alkenes that can be formed by the dehydrohalogenation of 1-iota 1-methylcyclohexane. Apply the Zaitsev rule to predict the alkene formed in the greatest amount. So first step is actually properly drawing this compound. So we've got 1-iota 1-methylcyclohexane. So there's your cyclohexane. There's your iodo, and that's your methyl. So the dehydrohalogenation, we're going to eliminate an HI off of this molecule to form an alkene. Zaitsev's rule is going to tell you that it's the major product's going to be the one where you have elimination from the most substituted carbon. So the reason why they're giving you this highly symmetric molecule is that you really got two unique points of elimination, here and here. Now Zaitsev's rule says that the elimination is going to come from the most substituted carbon, so this should be our major product. That said, if we do happen to go through an E2 mechanism, so for whatever reason our solvent favors that, we can get an elimination from that one. So let's see if I'm right. You know, it suddenly occurs to me that this is the test 4 material. I am so sorry for wasting you past 5 minutes of your time. Let's actually go back and let's look at the test 5 material, because that's probably what you actually have questions about. Couldn't figure out why that was so heavy emphasis on the alkanes. That makes a lot of sense now. Okay, sorry about that. Question 27 on the actual stuff that's like due next week. So the first one is asking about elimination. This looks like, okay. Yeah, I was like, I cannot figure out why like these are so alkene heavy. Like maybe they're building to a point. I was like, oh, that makes a lot more sense. That was the last material. So for this one, you got this monstrosity. Now, what's it's showing you, but not doing a very good job of showing you, is that this sodium acetylide is really just a very good nucleophile. So this is a good way to do carbon-carbon coupling reactions. Basically, this is going to act like any nucleophile, and it's going to substitute one of our halogens. Now, it can substitute both. I'm wondering here if this is just a substitution where it's just doing a single substitution or double substitution. Iodine is a much better leaving group than chlorine, so this is why, if you want to keep track of it, we don't ever talk about fluorination reactions because fluorine's such a good forms such a good bond that fluorine can't be eliminated. Iodine's the other extreme. It's so bad at forming bonds with carbon that it's really easy to eliminate. So first product you're guaranteed to get is this acetylene attaching to the very end. Now, the question is whether or not it does the full-on double elimination or not. So what I'm going to do is I'm going to draw it as if it does the first elimination. We'll see if that's what it's actually looking for. 2, 3. Triple bond. There you go. Where are my heteroatoms? So let's try this as a first approximation, see what it says. So there you go. So for that question, basically acetaldehyde, the hydrogen removed form of acetylene, that's just a nucleophile. It's going to displace, I would argue it could displace chlorine, but apparently according to literature it only displaces iodine very well. But yeah, that would be your first answer, is that basically your iodine here is going to get replaced with your triple bond, with your alkyne end. Question 29. Alkyne synthesis. So flip it over so you can see it on your end. So you've got So we're going to kind of cheat with this problem. And this is something I think I've talked about in synthesis problems online, but we're going to kind of cheat because we're going to use context here. We know that we're trying to form alkynes. So if we look at this reaction, we're going to get elimination because we had this tert butoxide. Now, if we're going to form an alkyne, we have to find two adjacent hydrogens because we're going to eliminate both chlorines. This only has one hydrogen, whereas this has three. So if we're going to do a double elimination, which is what this looks like this is predicting, you're going to end up only being able to do this product. Now, argument may be made, why don't you get elimination from here, and basically why doesn't the reaction stall out? I would say the explanation is that because this is such a big base, it's going to have trouble getting to the sterically hindered isolated hydrogen. But let's see if I'm right. Yeah, apparently so. So this is what it's predicting. Now, if your inclination was to say that, well, I really think it's going to follow Zaitsev rule for the first elimination and get rid of this hydrogen, I actually would be inclined to agree with you that probably what you're going to get as a majority product is this. Simply because your first elimination should be following Zaitsev's rule, and that first elimination should pick it off here. But again, we're going to kind of use the context of the problem. We know that this is an alkyne chapter, so odds are we are forming alkynes by this. The trick here, the reasoning here was to sit back and say which of the carbons adjacent to those chlorines have enough hydrogens to get you down to an alkyne. This carbon only has one hydrogen, so we can only do a single elimination. It leaves us with this one that will do a double elimination. So that kind of helping you out there? I agree with you. I think it should be that. And I think it's kind of odd that they're claiming. I mean, it would make sense from a steric standpoint that hydrogen's kind of wrapped around a whole bunch of carbon, so it's probably hard to get to. But like you, I think this is at least produced, and I would assume that you got a fair amount of this sitting in the reactor when you're done. Again, we're going to kind of cheat. Unfortunately, this is kind of the name of the game with the way organic chemistry is taught. We're going to cheat. We're going to put the problems in context. We know we're talking about alkynes, so we're producing alkynes. The final exam that you're taking next week doesn't involve alkynes because you've already taken your test on that. So that remaining 30% is everything beforehand. And again, I really hate teaching it that way, but it's kind of the way your textbook's laid out. You would see reagents in one chapter doing one thing, and then the same reagent in a different chapter does something different. This is part of the reason why I've also been trying to give you like open-ended questions that say, okay, this is the majority product, but what are the other things formed? Just so you do kind of walk down this line of reasoning and say, oh, well, if I did get something else, this is a reasonable answer. Other questions? Yeah, you're welcome, Claire. Fun fact, I have just now begun to start working on the Orgo 2 videos. So I'm putting the videos priority ahead of creating my problem packets. Usually it's the other way around. I'll make the practice packets and then I'll start doing the videos. But looking like the videos seem to be the most useful thing people are using this semester. So I'm going to try to make sure that, particularly with Orgo 2 this fall, we're going to start on good footing. Now, we did get an email yesterday. Wake Tech is banking on this fall pretty much being online. The proposal, when it's not online, is something insane. They were talking about doing half capacity labs. So unless they plan on doubling our lab space, I don't quite understand how that's going to work. But for those of you who are enrolling in this fall, probably online again. This spring, they're already talking about online courses. So yeah, just keep that in mind. Also keep in mind that we are getting our information from very high up. Shouldn't say very high up. It distills down from like the state level to us. So those of you who are going to be attending four-year universities this fall, I would bank on you also having online courses. Now, good for you in terms of your student debt because you're probably not going to be in a dorm, so you don't have to worry about paying for that. That said, be very realistic. You are probably looking at online courses through the end of the year. Now, the reason why we're probably not announcing this, and this is just speculation on my part, we don't want to contradict the governor's office, which is saying that, oh, phases are definitely a thing. I think they are serious about wanting to do a phase back. I think the governor's office is predicting that we will not meet the requirements for phase two until at least August. So while there is a framework for phasing things back in, I think they think, based on the responses we're getting and the planning we're doing, they don't think the pandemic's going to be over anytime before August, and most likely it's going to run through December. So congratulations, Gen Z. I think you found your big event that defined your generation, the pandemic of 2020. Yeah, you're very welcome, Hannah. Let's see here. There are 4 people watching. All right, the 4th person out there, you got any questions? By the way, I have been reading discussion boards. I actually strategically planned this one. I figured we all needed that catharsis for that last discussion board. I took online courses in college. I absolutely hated them. I took 2. I took an online ethics course and I took an online quantitative chemistry course. I do not function well with online courses. They very much become out of sight, out of mind for me. It also didn't help that it was chemistry 315 I took online. The guy's lectures and his videos, he changed his lecture order but never changed his videos. Oh, okay, good. So it looks like all 4 you got your questions answered. But yeah, I totally sympathize with you on this online transition because it was so hard for me to take online courses. I just could not study them. I always found something else to do. Even when I had the videos up, it was like, well, I'm sitting here, I might as well get some other work done. And then ultimately I found myself working more on my other work than ever watching the videos that were given to me. Luckily for Chem 315, there was a seated option, which after a month of nearly failing the course, I went right back to the seated option. The online ethics, he didn't want to teach the course, we didn't want to take it. So even though none of us really learned anything or did anything or participated in any way, we all still passed the class with an A miraculously. So yeah, totally sympathize with you on the discussion boards there. Do not enjoy, as an instructor, I don't enjoy this online format because I feel it's very hard to connect with students. I know a lot of you from the class, which is why the chat option is working for me right now, but definitely this summer and this fall, where students are more just kind of names on a screen, it's going to be kind of hard for me to engage with students. So yeah, good luck with you in that regard, but totally sympathize with you for the online courses. They are not, for some people, they work great. They're just not for me. And I don't think they're for most students. Right, if you're all good, we can finish up the last live stream. Again, thank you for your patience this semester, not just the pandemic, but the fact that this was my first time ever teaching the course. Definitely saw a lot of the growing pains with the first time you teach a course. It looks great to you until you teach it and realize maybe you didn't quite think it all the way through. But yeah, definitely thanks a lot. Those of you going on for Organic 2, wherever you go, please keep in contact. I do appreciate your feedback. I do want to know what helps you, what didn't help you, where you felt you were well prepared, where you didn't feel you were well prepared. That latter thing is very helpful, particularly when you go on to other schools. Other schools don't tell us what we're not doing well. mostly because they don't keep track of it. But it would be nice to know that you said, oh, we covered this, this was really helpful, or we didn't cover this, it would be better if you could cover this in more detail. Again, the goal here is to get our organic courses to the point that we are competitive with other four-year universities, and that students feel like they walk out of Wake Tech feeling like they got their money's worth out of the course. So again, please keep in contact. Please let me know what helped, what didn't help. Feel free to reach out if you have questions, homework questions, concept questions, any of that. All right, that said, there's no other questions. I'm gonna let y'all head out for today, and good luck with your exam next week. Do email me if you have questions. This exam is not meant to like make or break your grade. If you're genuinely having a question or need clarification, let me know. The exam is set up that you take it and then you have the option to redo it to correct your wrong answers. So the point here is to demonstrate mastery. They are multiple choice questions, so I'm not going to be looking at any work. That's why I gave you the second submission go around to sit back, because I know simple mistakes happen. But again, it's meant to be review. It's not meant to be make or break or super high stakes. Just to make sure that you leave this course understanding what you need to know in order to go on to be successful for Orgo 2. So, thank you all for showing up. Thank you for a good semester, and some of you I will see this fall, possibly in the spring. Otherwise, take care.